So this is a video solution to number 6 on the 2017 BC Calc exam. And A asks to show that the first 4 non-zero terms of the Taylor series are as given, and then to write the general term of the series. So we know just in general for Taylor series, this is the basic formula right here. So P then is approximately whatever that is. So our first step is to find the derivatives, and they give us the kind of formula for that up here. So we'd have f of 0 is 0, f prime of 0 is 1, and then f double prime of 0 is going to be -1 times f prime of 0, so times 1, which equals -1. F triple prime of 0 is going to be -2 times -1, which equals 2. And then f to the 4th of 0 is going to be -3 times 2, which equals -6. So the next step is just to plug all of these derivatives into our general equation. So we're going to have P4 of x equals 0 plus 1x plus -1 x squared over 2 factorial plus 2 x to the 3rd over 3 factorial plus -6 x to the 4th over 4 factorial. And then the next step is just to cancel. So that's going to become x minus x squared, and then 2 factorial is just 2, plus 3 factorial, which is 3 times 2 times 1, so the 2's cancel, 3 times 1, so it's just x to the 3rd over 3. And then x to the 4th, so but this is going to be a minus x to the 4th, and then 3 factorial equals 6. So the 6's cancel and you just get over 4. So then if we're trying to find the general formula for this, or the general term, we see that it's alternating. So we have to put the -1 to the n plus 1. And then we have x to the n over n, starting when n is greater than or equal to 1. So B asks, if we can scroll out here, to determine whether this series is absolutely convergent or conditionally convergent or diverges at x equals 1. So if we plug in x equals 1 to our Taylor equation, we get 1 minus 1/2 plus 1/3 minus 1/4. And if you recognize this right here, this is the alternating harmonic, which general form is -1 to the n plus 1 over n. And we know that the alternating harmonic converges. And we can see this because it is an alternating series with the terms getting smaller. So by the, But we also know that the harmonic diverges. And the harmonic is the absolute value of the alternating harmonic, which means that this series at x equals 1. So at x equals 1 is conditionally convergent, since the alternating harmonic converges. So the series converges, but the absolute value of the series doesn't converge, which is the definition of conditionally convergent. So moving on to part C, it asks us to write the first 4 non-zero terms in the general terms for g of x, which is the integral from 0 to x of f of t. So the integral from 0 to x of f of t dt. And this is just going to be the integral of all of the terms. So the integral of x minus x squared over 2 plus x to the third over 3 minus x to the fourth over 4. So when we integrate that, just using basic integration, we get x squared over 2 minus x to the third over 6 plus x to the fourth over 12 minus x to the fifth over 20. And then it asks for a general form of this new g of x. So this is approximately g of x, and a general term would be alternating, so -1 to the n times x to the n plus 2 over n plus 2 times n plus 1. So here for the x to the fifth, it'd be 5 times 4, so over 20. 4 times 3 over 12. 2 times 3 over 6. So you can see how we get that. And then this is for n is greater than or equal to 0. Finally, part D says let Pn of 1/2 represent the nth degree Taylor polynomial for g about x equals 0 evaluated at x equals 1/2, where g is the function that we found in part C. And it says use the alternating series error bound to show that P4 of 1/2 minus g of 1/2 is less than 1/500th. So the first thing to do with this is to remember that we're proving P4 of 1/2 minus g of 1/2. And by the alternating series error bound, we know that that error is going to be less than the next term, so less than P5 of 1/2. So, and that will be less than 500. So we have to look and try and prove this part right here. So P5 of 1/2 equals, and we're doing the absolute value. So the absolute value of -1/2 to the fifth over 20. And then 1/2 to the fifth is 1 over 32. So this becomes 1 over 32 times 20, which equals 1 over 640. And 1 over 640 is less than 1 over 500. So therefore, by the alternating series error bound, the error will be less than 500.